Good evening, everyone, and welcome to the 6th installment of the very successful and well-attended Members Presents presentation series. It's a short format presentation series loosely based on TED Talks, where a member or someone else interested in earthen construction talks about their work or their research or their interest in it, involvement with it. And before I introduce today's speaker, I'm first going to tell you about our upcoming speaker. It's Teresa Lopez with Green Energy Money, and she's going to be talking about all the mechanics of financing for green projects, which will include financing, marketing, and valuing of those projects. So that'll be excellent. We're looking forward to that. So if you can, come next month, which is August, first Tuesday in August at 7:15. And now for today, this is Esteban Barboza. He is an engineer in training, works for a local multidisciplinary engineering firm, and he graduated from Arizona State University. And he is going to be talking about his process of learning about Adobe construction that he started while at university there.
Thank you. Yes, so my name is Esteban Barboza, actually stated. And a quick about me. I was born in California and ended up moving to Texas and grew up here for the most part. And before I was lucky enough to get a partial scholarship to Arizona State, where I pursued civil engineering. After completing that in 2016, I moved back home and ended up getting a job here at GE Reese Engineering, where I tend to work in tension ponds, grading plans, all that kind of stuff, land development mostly. Hydrology for the most part is what I start, and that includes stuff like making sure when you build on the site, you're not flooding someone down the way, and tension ponds, as we were discussing earlier, and such matters. As far as hobbies, I do like to draw a lot, which kind of goes hand in hand with engineering anyway. So architecture was something I was interested in before that, so it's just natural process. Recreation sports, which is just like volleyball, soccer. So if you're looking for a league or need a team, just let me know. So this all started in Durango, Mexico. I had never heard of Adobe or had any knowledge of it until I went to visit family over there when I was about 8 years old. And after visiting all the relatives and getting to know everybody, all the adults had settled down for the afternoon siesta, and I wasn't tired at all. So I ended up going outside with some of my cousins, and they were all playing down the way, but I saw these ruins over here on the other side, towards the street, and I just kind of wandered over there by myself, which probably was unadvisable, but I was just really taken with it because as I'm walking over, I've seen these half-built Adobe houses kind of falling apart, but they had retained a lot of the structure. A lot of the walls were still standing, part of the roof was still up, and crossing that threshold, I just noticed just instantly the temperature drops a couple degrees, and it was really cool because I just have this, I guess, nostalgia kicking in, but it was just like the weather and everything. It just really stuck with me. But after that, I probably didn't think about Adobe again until college. So fast forward to college, and before I go on to that, on some advice from one of the members here, I actually contacted my grandpa back in Durango, and he sent me some of these pictures here. So here you can see some of the blocks already built. This is where the source that they were using to kind of form and everything. Down here, he spoke with some of the seniors of the town, and as far as I understood, that structure's been standing for well over 100 years, with somewhere here along the top, yes, you can see, but for the most part, it's still intact.
This is in Durango?
Yes, Durango, Mexico.
The city of Durango.
So it's right outside. So there's a city, Durango. The state is Durango. So it's Durango, Mexico. Right. But they live right outside in this little place, kind of La Soledad area. Here, these are just different kinds that are also in the area. here they were using Adobe for the most part with some reinforcement in the right here in the pillars here. It's concrete reinforcement with I believe steel reinforcement as well. The other one is largely Adobe with concrete finishes just to give it that clean look. So fast forward to junior year of university, and I'm taking a geotechnical class. So geotechnical is the study of soils, and I was really interested in that just because I was actually doing well in the class for a change. And what really stuck out to me was clay, and not because I knew about Adobe, I still hadn't remembered that memory from 8 years. I was 8 years old, but actually because my parents' house. As I don't know, I'm sure most of you know since you're involved in this business, but San Antonio was built largely on clay soils. So within this map, which is all largely within 1604, well over 80% of those soils have some form of clay, up 30%, 60%, wherever that range is. And it just so happened that when my parents moved, their house is built on clay soil. So common foundations here are pier and beam and concrete slab. So our house is built on concrete slab, and any experience that my parents were, they trusted the homeowner, getting inspections done, so oh, it's fine. Well, the rain comes, and that's when you realize that clay holds water very well, and which is fine at first. You'll notice after it rains that the ground soils kind of swell up. So if the house is in, the house will shift a bit, and you'll notice some of the doors start sticking or whatever the case may be. But then when the house is this huge load that's sitting on the soil, so slowly it's squeezing out that water, and that causes differential settlement. Differential settlement is it doesn't necessarily sit back down exactly where it was. Some of the house might tilt this way, some of them back that way, and it was so much so that if I put on rollerblades and I found a little ridge in the house, I could just let it go and carry me down with it. So after that, so that was why I was particularly interested in geotechnical engineering, the study of the soils, the foundation of the foundation, and everything. And it was during that studying time that I actually discovered there was a passing comment just mentioned Adobe, and that was what actually triggered that memory again. It's just like came back to me. It's like, whoa, this is something I really like, and maybe I should look into this. But as far as I knew, there weren't any outlets for studying this or pursuing it in the university. And maybe a few days later or a week later, one of my other classes, my professor mentions this research initiative, Fulton Undergraduate Research Initiative, or FEAR. In this program, he says you can, volunteer for to continue on someone else's experiments, research, but I didn't really want to do that. Most of these were transportation professors and everything, so they're studying asphalt samples, compression tests, crushing little concrete samples, and that's cool, but you get tired of it pretty fast. So when he went on to mention that he would be interested in supporting new research, I figured this makes sense. So I spent that whole semester trying to put a proposal together, and it was denied, and I had to get all my stuff together again, put in more research time, and then finally I found out that it was approved for my final semester of senior year. And this was just a quick follow-up. You can't really tell, this is a naturally listing, so like the house is squeezing the saturated soil and all the water is coming out. So it's just the way that the house settled. Swelling here as you know, and then the compression after it squeezed out all the water. So it was the spring semester of senior year, and I'm just going to go into a couple definitions here so that we we're all on the same page. The whole point of this was, in this research, I had to figure out how do I want to address this, and which variables are worth pursuing and which ones can I actually produce results with. So thermal conductivity is the property of a material to conduct heat, which is kind of in the title. But typical units for that are, as seen here, this is a British thermal unit per hour per foot per degree Fahrenheit, and this is just basically more English units, and this is metric. So I put both because, I mean, we really should be on metric, but that's besides the point. Specific heat capacity is the amount of heat needed to raise the temperature by 1 degree. So it's just the other side of that, making sure that we're not mixing them up so much. And thermal diffusivity is the thermal conductivity at a constant pressure, and it measures the rate of transfer or heat of material. So the whole point of mentioning these is that specific heat capacity is how much it's holding, where concrete might have the same low thermal conductivity as Adobe. The specific heat capacity, it'll start holding it, and if you step into an all concrete building, you might notice, especially if it doesn't have AC, how hot it gets in there just from the constant heat that it's releasing, and which you're surprised at when you compare it to Adobe. So I went on to with the knowledge of those values, I went on to starting my research. I started reaching out to local providers and trying to collect samples from all different places and trying to standardize, a value for thermal conductivity, because they were all over the place. It was 0.9 here, 0.75, whatever it was, and without that standardization, we're not going to be able to progress this building code as quickly as we like. So I started reaching out, and that's when I realized it's actually really difficult when you're the only one who has interest in this. So they're not going to follow up with me. It's like, oh, what do you need? And I said, no, it's I have to be bothering them. It's like, okay, go away. So some of them never got back to me. Others could, but I'd have to drive out to them, and that was really quite difficult for an out-of-state student without a car. And there were actually two that were rather accommodating. One was willing to bring samples all the way from Tucson to Tempe because he had business meetings in the area. And so I had a lot of correspondence with him, just going back and forth on different sizes, delivery times, dates, and then a day before, he says, I'm not going to be able to make it. I'm like, what? What do you mean? We've been planning this for quite a while. And he tells me, I had an accident. And he goes into details, like, yeah, I had a fall, I went to surgery, I was in the hospital for this many days, I got out, released this day. And I'm like, why are you telling me all this? I barely know the guy. But and he really meant well. He says, I'll be here in close by if you want to drive out and collect the samples. And I just couldn't make it out, so that was the end of that. And finally, I had one other source that was able to get back to me, and I had a friend actually drive out since it was the closest supplier, and we picked up about 4 bricks worth. These are, if I remember correctly, so it was 16 by 12 by 4 inches thick, and I'm sure some of the builders here know better than I do, but this is these are stabilized Adobe bricks. They did use, I believe, as asphalt binder of some sort to stabilize those. Just to clarify that, unstabilized Adobe is typically soil, water, and some form of straw, and it's just that's all there is to it. Whereas stabilized Adobe has emulsified asphalt or lime, cement, polymers, whatever the case may be, to help the integrity or provide properties that are desirable to the constructor. So at that point, go back real quick. I think I had a couple points on that. Did I address everything on that one? Yeah, okay, there we go. So I ended up talking to some of the people at the the university, and they suggested the thermal conductivity testing that is ASTM standard C117-04 for the guarded hot plate method, and that is might be dated now, but the way that works is, it's probably easier if I draw this. Okay, so there's So the way this works is there are 3 different panels. The guard heater, which generates the heat in this case, the cold plates, and then 2 soil specimens. Now, the guard heater generates the heat, and we put little sensors on the soil specimens here that tracks that, and then this ensures that this is the cool side, I suppose, so that way, going back to the definitions, you realize how much energy it requires to raise it 1 degree in temperature. So that was the whole point of the premise of this test. And I reached out to the last student that did this, and he agreed to help me out since this machinery hadn't been used in quite a while. The first problem was the samples were too big. I'm like, but that's part of the material. That's how it works. It says no, you need to get it down to ½ an inch thickness. It says, probably do 1 inch, maybe 2 inches, and I had to give it a shot and just figure out how I'm gonna make this work, because he said if you get it down to ½ an inch thickness, you reduce the margin of error, and that way you're able to quantify this better. Well, that was another adventure in itself, because I had to go talk to the other graduate students and figure out, okay, can I use this wet saw? And like, yeah, we'll let you in, you just have to clean up afterwards. I'm like, sounds good. I show up and I got my samples ready. I turn on the wet saw, and the water's supposed to keep the dust down, but on that first cut, I have a disassembled brick because all that water is turning it into a slurry. And I'm like, oh man, what am I gonna do? So at that point, I'm like, all right, I don't need this water. We're gonna do it like this, dry cut. Well, if you're okay with a couple sparks flying and a lot of dust being generated, that's how it went down. And I got these samples. Obviously this one's cracked, but there were other ones that made it. And that's how I spent my Saturday. It was just a good 6 hours of cutting this stuff. And if there was a mirror in there, I probably would have realized how much dust was actually created, because I was covered in it. But I didn't, and I finished these samples. I'm tired, and I cleaned the machine, cleaned the floors. I'm pretty sure half of my samples went down the drain that day. And then I left. That was good. That was good enough work for the day. Next morning, I get a call. Esteban, you cleaned the lab yesterday, right? Yeah. What do you mean? What's the problem? All the other machines were also covered in dust. So I got a bit of a stern talking to after that. And I was and that was how I learned about the saws there. At that point, I finally had these samples ready, and what they ended up, back one. Here, what's happening here is I ended up cutting them into 3-inch pieces of about 1 inch to 2-inch thickness with the same length of 12, because I needed 12 by 12 by ½ an inch for the test. But that was rather difficult. So they decided to give me a thermal epoxy to try and hold these things together. And so more and more of these samples were being disfigured from the initial process, and it was just I was very hesitant about how these results would actually compare to the original. So on to the next slide. At that point, it was already April, and we're like, it's time for you to submit and get ready for the symposium. And it's just left me no time. It's no time to actually get into the. I didn't have access to the building where the machine was, and then it was under a different professor, so it was even difficult getting to that. So all of this was just a uphill battle to get to. And right when I was finally figuring out the software and how to set everything up, was when I got the notice is that you need to wrap it up and you're done for the semester. So at that point, I turned something in, and a couple of days go by. I'm sitting in class, project management, getting my notes ready, and one of my peers walks up to me. He says, "You're Esteban, right?" It's like, "Yeah. What's up?" I didn't know you were working on Adobe. You should have told me. I'm like, "Oh, I didn't know you were interested." And he gives me a whole spiel. It goes on for a good 5 minutes, and class starts. And says, "Oh, we'll talk later." And 2 days later, when we have the next class, he comes up to me and he puts this down in front of me, just a big packet of notes and everything. So I have all this stuff here, and I want you to take a look at it. And at this time, I don't know if you might have guessed, but this was Kirk Higby.
Oh.
And Kirk, I guess he was going back to school at the time. And he was sitting on all the class, and I seen him around, but I didn't really talk to him. And so he's just expressing all his interest and support, which I was really grateful for. And so finally, the day of the symposium comes around, and I'm sitting there on my result list poster board, just kind of standing around. And Kirk comes up to me, and he tells me, thank you for continuing this research. It's been, I don't know how many years since the last person here at the university was studying Adobe, and I don't know if you can tell, but I'm holding this this spoon here because he inducted me to his Order of the Adobe Spoon.
Oh, right.
Right then and there. And that was the end of the semester. I mean, I wasn't able to continue my research anymore since I was done. But I came back home, and I didn't get a job right away in civil engineering. There was a lot of intermediate positions. So in that time, I would go to the library like once a week, and I was checking out books. And one that really stuck with me was, let me see if I have it, Adobe Houses for Today by Laura Sanchez and Alex Sanchez, which I believe are architects. And
Hold it up, please.
yeah, right here. So they basically designed a lot of different styles of homes for whatever the preference may be, and they designed it such that they were building blocks. You had an initial home that functioned well, and then if you wanted to add to it, it was capable of that. That you could expand rooms in ways that they prepared such that it just worked effortlessly. And they're discussing, there's a lot of science behind it as well, as like the south-facing windows and so and so. And it was just a really interesting read, and that I happened to enjoy. And it talked about different energy efficiency methods, just like radiant heating, just water pipes under the house so that the heat radiates up, as opposed to forced air, different materials like that. And I just really tried to get into that as much as possible. And it's kind of slowed down now that I have an engineering job where I have to pull late hours sometimes, but I'm still trying to put this together and build my own house at some point. And I think as far as energy efficiency, I'm in the right field for it. I appreciate the science side of it as well as the architectural design side, and I really look forward to continuing in this group. As far as continuing with this group, I have been trying to work in the fundraising committee and the technical committee, and I have Michael's short email. It printed weird, but his short email on his summary on what he's pursuing currently, and just a life cycle assessment of the buildings and how, while it might seem like it's more costly at the start, in long term Adobe is more cost effective, especially in its lifespan. Trying to study its hygrothermic, which is the movement of heat and moisture through buildings, checking the performance, as well as the IAQ, which is the indoor air quality of these buildings. And we're just trying to figure out how can we quantify this and get the support to make this a reality for people. And if you're interested in that, I mean, feel free to talk to either of us. And I actually didn't time this presentation at all, so I have no idea if I'm anywhere near the time limit. But I think that's about it. Yeah, so I covered those points just now. Independent research, just all the material he's given me, I'm finally getting a chance to look through it and getting more involved with it. And I realize there are builders here in this area as well, but as far as reaching out, I only contacted Dwellers, which is based in Dallas, I believe, and they have week-long trainings for learning how to build their blocks, the compressed earth blocks and everything, and just different stuff that I could find. I'm sure if we pull all of that, we could figure something out. So, any questions?
Well, thank you.
Thank you.
Can you tell us the story of the Adobe spoon?
Oh.
That logical connection is not there.
So he did tell me it, and I hope I'm telling this right. As far as I remember correctly, if I remember correctly, it was let me see. I believe the Adobe spoon was used as a striker, which when laying the brick. So as far as the plaster and everything and putting it together, this was the tool used for that in that case. And so he presented it for my research into the Adobe, and that's as far as I know. As far as I know, we're the only two members because he hasn't told me anything about anybody else.
There's quite a few members.
Okay.
Yeah. I think it probably started as Clinton's
Yeah.
order of the Adobe
Earth
spoon.
USA.
Yeah. So if you've been to Earth USA, you probably picked up an Adobe spoon and self-inducted into the order. But yeah. And that's also, Kirk is also how Esteban found out about ECI. If you want to mention that.
Oh, okay.
Yeah, a while back we had a business practices class where we had to make a Twitter account, and so for the most part everyone abandoned their Twitter accounts afterwards, but Kirk still uploads from all over the US just different articles or presentations, workshops that are occurring, so Colorado, Texas, New Mexico, Arizona, and it just so happened to be that he shared the flyer from, was it one of the first members presents? And I'm like, oh, that's here in San Antonio. I might as well go check it out. And after that first meeting, I knew I wanted to be a member, and I signed up right then.
We're so glad you are.
Yeah, you're the future.
So on your blocks, they were stabilized blocks?
Yes.
But then when you added water, they were melting?
Yeah, there was
That doesn't sound right.
with the saw going as fast as it was and the water combination, it was, I guess it just wasn't pulling together very well. The provider didn't exactly give me his mix either, so I don't know if it was like a company secret or not, but he didn't give me that. So it was just what he told me in person when I went to go pick him up, which was very little information.
Well, I would imagine too, if you're trying to cut it down to
1 inch thick.
Yeah.
That's
It's
that's not
nothing.
gonna be able to be too stable.
Which
Not your
defeats,
fault.
which
Not your
defeats the purpose of the test in the first place. So.
Commendable, you spent 6 hours doing it.
Oh yeah.
And all you forgot was that it was dust on the other.
Who was the provider? Who provided the?
It was Old Pueblo Adobe.
Okay, I
it was
know them.
Right close by. I was maybe 5-10 minutes away by car.
Yeah.
Pick up the samples.
How many providers did you find in the region overall?
In the area, within an hour's drive away, were probably 6 that I contacted at least, and maybe 4 came back to me. 2 were too far away for me to get to, and then it was the guy with the accident, and then Old Pueblo Adobe.
And were some of them new? Were some of them long established? You know,
Um, As far as I know, some of them had been there quite a while. They were recently branching out, and I think some of them were based in Tucson and were branching out to Phoenix and finally developing
so
suppliers
there's
there.
increasing demand.
Yes. They were successful enough to open up the second.
Interesting.
Any other questions?
How do we reach you?
How do we reach me? I have a business card to you, actually. So if you want to come up afterwards, we can discuss further.
Would you say what your email is?
Oh,
Spell it out.
let's see, I guess the contact one would be easier. Email is ebar011 at gmail.com.
Okay. Thank you.
Yeah, I actually teach online for Arizona State University.
Oh, really?
For, well, the Pacific Bend Community College, little school.
Right.
But, so it was interesting to me, and, it seems like you met a lot of frustration, which I would say is, I would say that is something that I've experienced too, but they also have a lot of innovation and stuff, so I'm wondering whether there were, places outside of engineering or anything that, you did get the award, but were there other people interested beyond that? And, do you see a future there, for these kind of studies and building them?
Well, it's kind of funny that you say innovation because Arizona State has that big promotion that they're number 1 in
Right,
innovation
right.
over MIT and Stanford. Always. But I didn't really have much contact with the architect community at that time, so as far as I know, they probably would have been the most interested in that. And there had been Adobe research before, but it had been, I guess, there hadn't been anyone to pick up that on that. So I was completely unaware of that history until Kirk told me. I did meet a lot of frustration. So actually, in my poster board, in my acknowledgements, I put, I would like to thank the graduate students and lab managers for tolerating my inexperience. I promise it was just a learning curve. That's the title.
Because they're big on sustainability too, and it's
Right.
it's
There were actually, of course, we took sustainable systems of some sort, but basically the whole idea was when we develop these technologies or bring them back, how are they going to be used beyond what is initially intended? And so, are there any foreseeable problems as far as like supply and how these people end up using it? And I think as far as affordability, with these basic designs, which I read about in this book here by the Sanchez architects, they seem to have very basic designs that could be employed as far as for low-income housing or anyone in general who could, and that way they could start with that. Because some of these they even studied how much square footage is really necessary for a person and how the square footage of a home is really quite excessive in some ways. You don't really need all that much space to function, and that's why they were able to design most of these pretty small to start. And if you want to expand, you have that option.
the Center for Bio-Inspired, Bio-Mediated Geotechnics part of the College of Engineering?
I don't believe so. My school was the School of Sustainable Engineering in the Built Environment, and that encompassed civil engineering, environmental, and sustainable engineering was just barely starting to poke its head out as its own major at that time. So it was more of a catch-all for civil engineering, and if you had an environmental focus, then you might get some of that as well. Biomedical was more on its own side, biological was its other, but geotechnical is probably the closest we came to that.
Okay.
Cool. Thank you, everybody. I think that's the end of our members' presents for this session. So thank you all for coming.
Yeah.
And
Thank you.
one after video announcement is anybody who wants to join, we're going to go to Kimura afterwards for